In this series of videos, we're going to explore exponentiation of exponential expressions, which is a fancy name of saying what happens when we take an exponential expression, like for example x squared, and we raise it to some power, let's say 5. What's the correct way to simplify this? And it's given by this rule, a to the power of m to the power of n is a to the power of m times n. In other words, you multiply the two exponents and you keep the base. So if you were to have a squared raised to the 5th power, you would say this is a to the power of 2 times 5, which is a to the power of 10. This rule is very often confused by students with the rule that says that if you multiply a squared by a to the 5th, you have a to the power of 2 plus 5, which is a to the power of 7, right? Saying a squared times a to the 5th is not the same as saying a squared raised to the 5th power. And if at any point you are looking at a problem like a squared to the 5th and you're stuck, you're saying to yourself, I'm not sure which rule to use here. I forget, do I add or do I multiply the exponents? You can always expand this as repeated multiplication. A squared times a squared times a squared times a squared times a squared 5 times, right? Because you're raising to the 5th power. And from here, you should see that since you're multiplying, you're adding the exponent. It's a to the power of, 2 plus 2 plus 2 plus 2. That's the 2 times 5, which is 10, right? You can always rewrite this as repeated multiplication and make some sense of it. So this is the rule, and we're going to take a look at several examples, one in this video and a few more in the future. It's not a terribly big idea by itself. You just need to do some practice to internalize it. But first, let's take a look at maybe a somewhat unusual question, at least for us. We have this statement 4 to the 6th power, and the question is, it's equivalent to 16 raised to what power, right? We're trying to find x. And let me start by saying that this is not the same type of an equation that we solved before. Up to this point, we solved exclusively linear equation. If we were to classify this, we would have to say this is an exponential equation because the variable we are solving for is in the exponent. And solving these equations in general is actually somewhat complicated. You have to use the opposite of exponents, which when you take higher level math you'll learn are called logarithms. But for this particular problem and problems like it that we will see in this section, you can use a clever idea. And that idea is that you can rewrite 16 as 4 to the 2nd power. The reason why you would want to use a 4 is because of this 4, right? 14 squared is 16. So what you have now is 4 to the 6th power equals 4 squared to the power of x, right? 4 squared is the same thing as 16. And from here, we can continue, right? 4 to the 6th power equals, Well, remember, we have to multiply these guys. So 4 squared to the power of x is 4 to the power of 2x. And for these to be equal, 6 and 2x have to be equal, right? So 6 equals 2x. And we all know we can just divide both sides of the equation by 2. And x equals 3. And if you wanted to, you could plug this into a calculator to verify that 4 to the 6th power and 16 to the 3rd power both equal the same thing. So this trick is something that I wanted to share with you. It's really, really useful in solving these equations. Let's do maybe one more example just so that you get a better feel for it. Let's say that we have 2 to the power of 12 is equal to 8 raised to the power of x. Again, the idea is we know that 8 is the same thing as 2 raised to the 3rd power. So instead of 8, we can write 2 to the 3rd power to the power of x. We can multiply these exponents now to say that 2 to the power of 12 equals 2 to the power of 3 times x, or 3x. And now that the bases are the same, 12 and 3x must be equal to each other. And if we divide both sides by 3, you see x equals 4. And again, you can try to verify that 2 to the power of 12 equals 8 to the power of 4.